In the previous video, I gave you a vague explanation. So in this video, I'm going to give you an example. So now we are on Earth. Gravity, we're going to round off to 10 meters per second squared. We're going to fire a cannonball at 60 meters per second at an angle of 50. The height of this hill is 40. So the cannonball will travel something like this. Calculate the range here. Okay, so the first thing to do, break this bit up. Okay, so it should be like this. Yeah, so this is your vertical and this is your horizontal component. Then jump to your velocity time graph. Velocity time graph here. This point here, which is, let's call it T max, is this point here. Okay, and this point here is this point here, and this point here is this point here. So your velocity time graph will look like this. You need remember we are trying to find out the total flight time. You see, this total flight time is actually quite hard to find because you've got to find out the actual height here. Once you've got the actual height here, then imagine you standing on top of a building here. Get the height here, add it to this thing here, which will give you the total height of the building. And then you're going to drop a cannonball and see how long it takes to hit the ground. Well, anyway, we are trying to find out the flight time. Okay, but in order to find out the flight time, we've got to find out the time it takes to get to its maximum height in order to find out the actual height. If you know, well, there's a lot to follow, so you just watch it through. So at the moment we are trying to find out the time it takes to get to the maximum height here, and then we can find out the actual height. Well, let's just find out the time it takes to get to maximum height. So this here would be, this is your velocity time graph. The equation for this line here is given by this here. Well, at the maximum height, the velocity will be 0. So we're going to put the 0 into this v here. Okay. So it will look like this. Put 0 into the v. Yeah. We're gonna. Yeah. I took 2 steps here. Put 0 into the v here, and then add 10t to both sides. So it will look like this now. Okay. And then work backwards to find out t. So t here is this. So this t here represents the time it takes to get to the maximum height. So this t here represents the time here it takes to get to this bit here. Remember, going along here represents time. So as time goes on here, there we are at the maximum height here. So this length here is this. Okay. So now we've got the time. Now that we know the time it takes to get to the maximum height, we can find out the actual maximum height. So your velocity time graph here, remember this bit here represents this line, this length here, well, the time it takes to get to the maximum height. Well, the actual maximum height is given by the area underneath the velocity time graph. So this height here is this. Well, we just will need to know this area here. So it's this times this. Okay. So yeah. So remember, we need to know the actual height. So we need to know the actual distance of the maximum height in meters. So it's basically get this times this here. Okay. So it's this times this, and then because it's half of a rectangle, we've got to divide it by 2. So divided by 2 here, and then well, at the moment you've got this times this, and then times this 6, and then times this. So merge the 2 numbers together, that will give you this, and then sine 50 times sine 50 is sine squared 50, and then divided by 2. Okay, so dividing it by 2, you can imagine it as like this: 360 over 2 sine squared 50. So you can take it out like this. So this thing here is 180 times this thing here. Punch it into your calculator, and it will give you this. Remember, to do this in your calculator, just work out sine 50 first. Maybe press equal, and then square the answer. Okay. So So this thing here represents the actual maximum height in meters. Okay, so our diagram will look like this. Now we know the actual distance. Now this here represents the actual distance in meters, and then add it to this thing here. That will give us the whole height. Okay, well, you don't need to say let z equals this. Just get this height, add it to this, because in the previous video I said let z equals this, because I couldn't be bothered to write out the really long formula, so I just call it z. Well, anyway, let z represent this height here, and then add it to this height here. So basically this is this, and then add the 40 here. That will give you the total height. So the total height of this thing here, the total height here is given by this. Okay, so now you can imagine. Remember, we've just worked out the total height here. Imagine you're standing on top of a building here, and you're going to drop a cannonball. The height of the building is this here. Okay, so now that you know the actual height here, you know the actual height here. Imagine you are standing on top of a building now. Okay, so this is you standing on top of the building, dropping the cannonball. Remember that the actual height of this building here is given by this. So the minute something's free falling, you got to visualize this formula here. Okay, so h in this case is z, our z here, the actual height of the building is given by this. So you can put this into the z here. Okay, so this, well, that's this thing here. So basically this here becomes this. Okay, because z here represents the height of the building here. So, and the total height of the building is given by this. So now it's just a matter of working backwards to find out the time it takes for the cannonball to free fall from here to here. Okay, so work backwards here, blah 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 blah. So t equals this. So it takes 5.4 seconds for the cannonball to free fall from here down to here. Okay, it takes this. Okay, so now remember, we've just worked out it takes 5.4 seconds to free fall from the top down to here. Remember that the time it takes to get to the maximum height is given by sine 6 sine 50. Scroll back. Earlier we worked this out. So now punch this into your calculator to turn it into a decimal. So now we now know that it takes 4.6 seconds to get to the maximum height, and it takes 5.4 seconds to free fall down to here. So the total flight time would be this plus this, the total flight time of the cannonball. Okay, so total flight time equals the going up here. This is the going up plus the going down here. Okay, add the two together, it comes to a coincident 10. Okay, so the total flight time is 10 seconds. So now that we know this thing here, it takes 10 seconds to fly like this. Okay, so now, well, the total flight time is 10 seconds. Now imagine you and your dad sitting in a car driving along here at driving horizontally at 60 cos 50. Remember, we broke this down earlier, right at the start of the video. So this here, so you and your dad sitting in a car driving along for 10 seconds. Okay, so the range equals the speed times the flight time. The flight time is 10, don't forget. So put 10 into the flight time. So that will be this times 10, and then we'll get 10 times with the 60 here. That will be 600 cos 50. So you punch it into your calculator, and that will give you the range. Okay, so the range here is so this range here is given by this. Okay, in the next video you can have a go for yourself.